Hello, in this lecture we'll find out the area of the circle that is inside square ABCD. In the drawing we have square ABCD. Inside this square we have a circle and also a right triangle. Angle BCT, this angle equals to 30 degrees. Line segment PD equals to 5 degrees. And our mission is to find out the area of this circle that is inside square ABCD. Okay, so first of all, we'll define the center of this circle as O. We join points O and P together by a straight line. Point O is the center of the circle, point P is the point of the circle itself, therefore OP is the radius of the circle that we define as R. And we have side D is tangent to the circle at point P. Point P is the point of tendency. And we have rule number 1. That the tangent to a circle is perpendicular to the radius drawn to its point of tendency. Here we have tangent AB, that is tangent to this circle at point M. Point M is the point of tendency, and we have the radius OM that is drawn to the point of tendency. Therefore, according to this rule, tangent AB will be perpendicular to the radius MO. That is to say, this angle, if AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to this rule number 1. So here we have the radius OP that is drawn to the point of tendency. Therefore, according to rule number 1, here this angle will be equal to 90 degrees. And this angle is also equal to 90 degrees. Likewise, we join points O and Q together by a straight line. Point O is the center of the circle, point Q is the point of the circle itself, therefore OQ is the radius of this circle that is equal to R, and again we have the radius OQ that is drawn to the point of tendency. Here side AB is tangent to this circle at point Q. We have the radius OQ that is drawn to the point of tendency. Therefore, according to rule number 1, tangent AB will be perpendicular to radius QO, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. We know that all the angles inside a square are right angles, so all the angles inside this square ABCD are right angles, so this angle it is equal to 90 degrees. This angle it is also equal to 90 degrees. This angle inside square ABCD equals to 90 degrees. And finally, this angle it is equal to 90 degrees. So inside quadrilateral POAQ, this quadrilateral, we have 1, 2 free right angles. The sum of free right angles is 270 degrees plus the size of the fourth angle. In total, the sum of those 4 angles, they must be equal to 360 degrees. Here I write it down. 270 degrees. That is the sum of the three angles, plus the size of the fourth angle, that is angle QOP. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract 270 degrees from this equation, and we get that the missing angle QOP, is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. So this angle, it is a right angle. So actually, we found out that quadrilateral POAQ has four right angles. Therefore, we relate to quadrilateral AQPO as a rectangle, because it has four right angles. And we know that the opposite sides of a rectangle are equal to each other. That is to say, PO equals to AQ. PO equals to AQ. But we already found out that PO equals to R, it is the radius of the circle. So we write here that PO equals to R, and from this equation R equals to PO equals to AQ, we derive that AQ is also equals to R. AQ is equal to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that AP equals to QO. AP equals to QO. But we know that QO equals to R, it is the radius of the circle, so we can write here that QO equals to R, and from this equation AP equals to QO equals to R, we will derive that AP is also equals to R. AP equals to R. So we found out that AP equals to R, therefore quadrilateral AQPO is a square because it has four equal sides, all equal to R. Okay, so we can write down that quadrilateral AQPO, this quadrilateral, is not a rectangle but a square. We know that all the sides of a square are equal to each other, so all the sides of square ABCD are equal to each other. That is to say, AD equals to AB. Here, AD equals to AB. AD equals to AB. So here, AD equals to AB. According to the rule that all the sides of a square are equal to each other. What is the length of AD? AD equals to 5 plus R. AD equals to 5 plus R. And it is equal to AB. What is the value of AB? AB equals to R plus QB. AB equals to R plus QB. AB equals to R plus QB. Here we subtract R from this equation, and we get that 5 equals to QB. QB equals to 5. So found out that QB equals to 5. And we have also rule number 2, according to rule number 2, the lengths of two tangents from a common external point to a circle are equal. We have the common external point P. From the common external point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule number 2, they are equal to each other. That is to say, PA equals to PB. This is rule number 2. So we can implement rule number 2 in our drawing. Why? Because in our drawing, if we focus on the common external point B, from the common external point B, we have two tangents to this circle, tangent BQ and tangent BS. And according to rule number 2, they are equal to each other. Because again, tangent BQ equals to tangent BS according to rule number 2. Again, BQ equals to BS according to rule number 2. But we have already found out that BQ equals to 5. So we can write here that BQ equals to 5. And from this equation, 5 equals to BQ equals to BS. We will derive that BS is also equals to 5. BS is equals to 5. Here we found out that BS equals to 5. Okay. So here, angle ABC equals to 90 degrees. While angle TBC, this angle equals to 30 degrees. So what is the value of the missing angle? The value of the missing angle will be equal to 90 degrees minus 30 degrees. That is to say, this angle will be equal to 60 degrees. This angle equals to 60 degrees. In the next step, we will join points Q and S together by a straight line. And we will focus on triangle QSB. In triangle QSB, we have side BS equals to side BQ. They are both equal to 5 units. In triangle QBS, side BQ equals to side BS. They are both equal to 5 units. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front the equal sides must be equal to each other. That is to say, if we define this angle as alpha, then this angle must be also equal to alpha because of the fact that they are equal to each other. Okay, so inside triangle QSB, we know that the sum of the angles must be equal to 180 degrees. This angle equals to 60 degrees, so the missing angle, the two other missing angles, they must be equal to 180 degrees minus 60 degrees, that is 120 degrees. That is to say, alpha plus alpha equals to 120 degrees. Here we can write down that alpha plus alpha equals to 120 degrees. Alpha plus alpha is 2 alpha, that is equal to 120 degrees. Here we divide this equation by 2 and get that alpha equals to 60 degrees. So here, this angle alpha equals to 60 degrees. And this is angle alpha that is also equals to 60 degrees. Therefore, inside the triangle QSB, we have three angles that are all equal to 60 degrees. That is to say, quadrilateral QSB is an equilateral triangle. I write it down. Quadrilateral a triangle QBS is an equilateral triangle. Why? Because it has three angles that each of the three angles is equal to 60 degrees. Therefore, triangle QBS is an equilateral triangle. And we know that in an equilateral triangle, all the sides are equal to each other. So those two sides are equal to 5 units. Therefore, side QS must be also equal to 5 units. Here we will join points O and S together by a straight line. Here point O is the center of the circle, point S is the point on the circle itself, therefore OS is the radius of the circle that is equal to R. And we have the radius OS that is drawn to the point of tendency, therefore this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. Okay, so in the next step I will copy quadrilateral QBSO in a new page and we analyze quadrilateral QBOS. Okay, so here I'm copying on quadrilateral QBOS. So inside quadrilateral QBOS, this angle equals to 90 degrees. This angle equals to 60 degrees. And finally, this angle equals to 90 degrees according to rule number 1. So actually, this is quadrilateral QBOS that I copied from the original drawing. We know that the sum of the angles in any quadrilateral is equal to 360 degrees, and especially in quadrilateral QBOS. Therefore, 360 degrees minus the sum of those three angles must be equal to the sum of the missing angle. That is to say, 360 degrees minus 90 degrees minus 60 degrees minus 90 degrees, it must be equal to the size of the missing angle. So here 360 degrees minus 90 degrees minus 60 degrees minus 90 degrees, it is actually 360 degrees minus 240 degrees, 360 degrees minus 240 degrees, it is equal to 120 degrees. So we found out that this missing angle equals to 120 degrees. Okay, here this is the missing angle inside quadrilateral BOSOQB. We found out that this missing angle equals to 120 degrees. Here, angle SOQ, angle SOQ equals to 120 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay. In the next step, we will focus on the green triangle QOS, but before that, I will present to you the law of cosines. According to the law of cosines, that is true in any triangle. If we have a triangle ABC that could be any triangle, this is triangle ABC. Side AB equals to A units in its length, side AC equals to B units in its length, side BC equals to C units in its length, and the angle between side AB and side AC is theta. Okay. According to the law of cosines, we get that C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. And this is true in any triangle. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. We will implement the law of cosines in the green triangle SOQ. The green triangle SOQ. This is the green triangle SOQ that I copied from the original drawing. We will implement the law of cosines in this triangle SOQ. According to the law of cosines, we get that 5 squared equals to R squared plus R squared minus 2 times R times cosine 120 degrees. So this equation is the implementation of the law of cosines in this triangle SOQ. Again, 5 squared equals to R squared plus R squared minus 2 times R times cosine 120 degrees. 5 squared is 25. That is equal to R squared plus R squared is 2R squared minus 2 times R is minus 2R squared times cosine 120 degrees. Cosine 120 degrees is minus 1 over 2. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. In conclusion, found out that 25 equals to 2R squared, and we have minus times minus is plus. So this expression in total will be equal to plus R squared. Again, minus times minus is plus, so it is plus R squared. So we found out that 25 equals to 2R squared plus R squared, that is to say 25 equals to 3r squared. Okay. So I found out that 25 equals to 3r squared. Here we divide this equation by 3 and we get that r squared equals to 25 over 3. And we know that the area of any circle is equal to pi r squared. That is to say, it is equal to pi, and we have already found out that r squared equals to 25 over 3, so we substitute r squared by 25 over 3. So we actually found out that the area of this circle is equal to pi times 25 over 3 square units, or in terms of numbers, it is equal to 26.18 square units. Repeat again, the area of this circle is equal to either 25 pi over 3 square units, or in terms of numbers, it is equal to 26.18 square units. We finished the question. The next step, I will summarize the lecture. So, we have here square ABCD. Inside square ABCD, we have a circle and also a right triangle. And our mission is to find out the area of the circle that is inside square ABCD. Okay? So here we defined the center of this circle as O. Here AD is the point of tendency. Point P is the point of tendency of tangent AD with this circle, and we have also side AB is the point of tendency, or point Q is the point of tendency of tangent AB with this circle. We join points O and P together by a straight line. Point O is the center of the circle. Point P is the point of the circle itself, therefore OP is the radius of the circle that we defined as R. We have the radius OP that is drawn to the point of tendency, therefore according to rule number 1, that a tangent to a circle is perpendicular to the radius drawn to its point of tendency. Here we have tangent AB that is tangent to this circle at point M. And we have the radius of M that is drawn to the point of tendency, therefore tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to this rule, rule number 1. So, therefore, according to rule number 1, we have the radius OP that is drawn to the point of tendency, therefore this angle will be equal to 90 degrees and this angle is also equal to 90 degrees. Likewise, we join points O and Q together by a straight line. Point O is the center of the circle, point Q is the point of the circle itself, therefore OQ is the radius of this circle that is equal to R. We have the radius OQ that is drawn to the point of tendency, therefore this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees according to rule number 1. And we also know that all the angles inside square ABCD are right angles, so those 4 angles are all right angles. And especially this angle inside square ABCD is a right angle. So we actually found out that inside quadrilateral AQPO we have 1, 2, 3 right angles. the sum of three right angles is 270 degrees plus the size of the fourth angle. In total, they must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. I repeat again, the size of the three angles that is 170 degrees plus the size of the fourth angle, three right angles, the size of three right angles is 270 degrees plus the size of the fourth angle, that is the angle that is missing. In total, they must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation. We got that the missing angle QOP is equal to 360 degrees minus 270 degrees. It is equal to 90 degrees. So this missing angle is equal to 90 degrees. So we actually found out that inside quadrilateral AQPO we have four right angles. Therefore quadrilateral AQPO is a rectangle because it has four right angles. And we also know that the opposite sides of a rectangle are equal to each other. That is to say AQ equals to PO. AQ equals to PO, but we have already found out that PO equals to R. So we can write here that PO equals to R, and from this equation R equals to PO equals to AQ, we derive that AQ is also equals to R. Here, AQ equals to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we'll get that QO equals to AP. QO equals to AP, but we already found out that Q equals to R, so we can write here that QO equals to R, and from this equation AP equals to R, Q equals to R, we will derive that AP is also equals to R. Here AP equals to R, therefore we found out that quadrilateral AQPO is not a rectangle but a square because all of its sides are equal to each other, they are equal to R. Okay? Then I presented to you rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. We have the common external point, point P. From the common external point, point P, we have two tangents to the circle, tangent PA and tangent PB. And according to rule number 2, they are equal to each other. That is to say, PA is equal to PB. We can implement rule number 2 in our drawing. Why? Because in our drawing, if we focus on the common external point, point B, from the common external point, point B, we have two tangents to the circle, tangent BQ and tangent BS. And according to rule number 2, they are equal to each other. That is to say, here we have BQ equals to, according to rule number 2, BQ equals to BS. Again, BQ equals to BS according to rule number 2. Okay, BQ equals to BS according to rule number 2. BQ equals to BS according to rule number 2. But we have here, but before that, actually, we know that all the sides inside a square are equal to each other. That is to say, side AB of square ABCD equals to side AD. AB equals to AD. So inside square ABCD, we know that side AD equals to side AB. So, what is the value of side AD? Side AD equals to R plus 5. Side AD equals to 5 plus R. And what is the value of AB? AB equals to R plus QB. AB equals to R plus QB. Okay? Again, AD equals to AB, and AD equals to 5 plus R, and AB equals to R plus QB. Okay, so here we subtracted R from this equation number 1, and we found out that 5 equals to BQ. BQ equals to 5 units. Here, this side BQ equals to 5 units. Okay, and then we implemented on the common exam point B, rule number 2. According to rule number 2, we have two tangents from point B to the circle, tangent BQ and tangent BS. And according to rule number 2, BQ equals to BS. Okay? BQ equals to BS. BQ equals to BS. Here, if we focus on the common exam point B, we know that according to rule number 2, BQ equals to BS. But we have already found out that BQ equals to 5 units. Here BQ equals to 5 units. And from this equation, 5 equals to BQ equals to BS, we will derive that BS is also equals to 5 units. Here BS is also equals to 5 units. Okay. Then we joined points Q and S together by a straight line. In this way, we created triangle BSQ or QBS. So inside triangle QBS, we have two sides that are equal to each other. BQ equals to BS equals to 5 units. I repeat again, inside triangle QBS, BQ equals to BS, and they are both equal to 5 units. BQ equals to BS equals to 5 units. It is not according to rule number 2, of course. We already found out that those two sides are both equal to 5 units. Okay? So we know that in triangle QBS, those two sides are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front, the equal sides, must be equal to each other. So if this angle is alpha, then this angle must be also equal to alpha because of the fact that they are equal to each other. So those two angles, they are both equal to alpha. And this in triangle QBS, this angle equals to 60 degrees, therefore the rest two angles must be equal to 180 degrees minus 60 degrees, that is 120 degrees. That is to say, alpha plus alpha, in total, they must be equal to 120 degrees. Here, alpha plus alpha must be equal to 120 degrees. Alpha plus alpha is 2 alpha, that is equal to 120 degrees. We divided this equation by 2, and we got that alpha equals to 120 degrees over 2, that is 60 degrees. So this angle equals to 60 degrees, and this angle also equals to 60 degrees. And we have only found out that this angle equals to 60 degrees. Why? Because angle ABC equals to 90 degrees. Angle CBT equals to 30 degrees. So the missing angle must be equal to 90 degrees minus 30 degrees, that is 60 degrees. So inside triangle QBS, we have three angles that are both equal, they are all equal to 60 degrees. Therefore, triangle QBS is an equilateral triangle. Okay, triangle QBS is an equilateral triangle, and we know that all the sides of an equilateral triangle are equal to each other. So this side equals to 5 units, this side equals to 5 units. So the third side must be equal also to 5 units because all the sides in the equilateral triangle are equal to each other. So the missing side QS must be also equal to 5 units. Okay. Then we actually have here quadrilateral QBOS. We joined points O and S together by a straight line. Point O is the center of the circle. Point S is the point of the circle. Therefore, OS is the radius of the circle that is equal to R. And we have the radius OS that is drawn to the point of tendency. Therefore, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay? So then I copied quadrilateral QBOS in a new page and analyze triangle QBS. Here, this is quadrilateral QBS. This angle equals to 90 degrees according to rule number 1. This angle equals to 60 degrees. This angle equals to 90 degrees, and this is the missing angle. Again, we have this angle equals to 90 degrees, this angle equals to 60 degrees, and this angle also equals to 90 degrees according to the same rule, rule number 1. So this is the missing angle. And we know that the sum of the angles in any quadrilateral is equal to 360 degrees. So 360 degrees plus minus the sum of the three angles, the sum of those three angles must be equal to the size of the fourth angle. 360 degrees minus 90 degrees minus 90 degrees minus 60 degrees must be equal to the missing fourth angle. 360 degrees minus 90 degrees minus 60 degrees minus 90 degrees, it is 120 degrees. So I found out that the missing angle SOQ equals to 120 degrees. This is the missing angle that is equal to 120 degrees. Then I presented to you the law of cosines. The law of cosines is true in any triangle. So here, this is triangle ABC that could be any triangle. The length of side AB is A units, the length of side AC is B units, and the length of side BC is C units, and the angle between side AB and side AC is theta. Then, according to the law of cosines, we get that C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Okay, so implemented the law of cosines in the great triangle, triangle QOS. I copied triangle QOS here, and we implemented the law of cosines in this triangle, triangle QOS. In this triangle, triangle QOS, according to the law of cosines, we get that 5 squared equals to R squared plus R squared minus 2 times R times cosine 120 degrees. Again, 5 squared equals to R squared plus R squared minus 2 times R times cosine 120 degrees. 5 squared is 25, R squared plus R squared is 2R squared, minus 2 times R is 2R squared, cosine 120 degrees is minus 1/2. So we substitute cosine 120 degrees by minus 1/2, by minus 1/2. And we found out that 25 equals to 2R squared. Here, minus times minus is plus. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So this expression in total equals to plus R squared. So we found out that 25 equals to 2R squared plus R squared. 2R squared plus R squared is 3R squared. So in conclusion, I found out that 25 equals to 3R squared. 25 equals to 3R squared. We divided this equation by 3 and found out that R squared equals to 25 over 3. And we know that the area of any circle is equal to pi R squared. So the area of this circle will be equal to pi R squared. So it is pi times R squared. And we already found out that R squared equals to 25 over 3. Therefore, we substitute R squared here by 25 over 3. And found out that the area of the circle, the area that we are looking for, equals to either 25 pi over 3 square units, or in terms of numbers, it is equal to 26.18 square units. Okay? Again, the area of this circle equals to either 25 pi over 3 square units, or in terms of numbers, it is equal to 26.18 units. Okay, thank you very much.